Dilations. A dilation is an enlargement or a reduction of a figure. So basically, on the coordinate grid, you're making a figure larger or smaller. A few more things about dilation. So it is a non-rigid motion, meaning it does change the size of a figure. So out of the 4 transformations, you have reflection, rotation, and translation. Those are all rigid motions. They do not change the size of a figure. Dilations is the only transformation that changes the size of a figure. It does, however, produce a similar figure because it does have the same proportions. And also all corresponding angles are congruent and all corresponding sides are proportional. So now when we're using dilations, we use the scale factor. And the scale factor basically shows how much the figure will be enlarged or how much the figure will be reduced. And that is the ratio of the length of the image to the corresponding length of the pre-image, with the image length being the numerator, and we'll discuss that further in the lesson. So basically an enlargement is if it has a scale factor that is greater than 1. A reduction has a scale factor that is less than 1. So enlargement, the figure gets larger. Reduction, the figure is reduced or gets smaller. So now we're determining the scale factor. And if you recall in our previous slide, to find the scale factor, we're going to write a ratio of the length of the corresponding sides, with the image length being in the numerator and the pre-image length being in the denominator. So of course our corresponding sides are right here. And we're just going to write a fraction with our image side length being in the numerator. So 15 divided by 5, and we simply reduce it. That gives me 3. So my scale factor is 3, or you could ask yourself, going from the pre-image to the image, 5 times what will give me 15? 5 times 3 will give me 15. So either way, you're going to get the same answer. In this case, our scale factor is 3. And of course, that would be an enlargement because my scale factor is greater than 1. Okay, so we have another problem here where we're finding the scale factor. But in this particular problem, we have a image within an image. So if you recall that whenever you see the apostrophe after the letter, that is the image. So our pre-image is the black triangle right here. So our pre-image is x RT. Our image would be x prime r prime t prime. And so we want to do the same thing, write a ratio with the image, the length of the image being in the numerator. And so if we look right here, okay, these are my corresponding sides. All right, so the length of that larger triangle, which is the blue triangle, which is our image, the length of this side here is 12 because 4 plus 8 equals 12. And so in my numerator, I will have 12. And then this smaller side here would be the length of my pre-image. That is 4. 12 divided by 4 is 3. So again, in this case, my scale factor is 3, and of course that would be in enlargement. Okay, so we have another example here of determining the scale factor, another image within an image. In this case, the pre-image being the larger figure here, and that is denoted by the fact that it doesn't have apostrophes right here. We have our apostrophes here, so A, B, C, D prime, that would be our image. So the lengths of our corresponding sides are 6 and 3. And remember, we always write the length of our image in the numerator. So in this case, we will write it as 3 over 6. And that reduces to 1/2. So since that is smaller than 1, that is a reduction. Or you could simply say that, okay, my image got smaller, so that is a reduction. So just remember, when you're finding the scale factor, always put the length of the image in the numerator. Okay, so in this particular problem, we want to find the coordinates if we're given a scale factor. So this problem asks, it says, what are the coordinates of the vertices of the image after a dilation with a scale factor of 2 and the center of dilation at the origin? And so a rule here states that when centered at the origin, the scale factor, we use the letter K, and basically you're multiplying the scale factor times your x value and the scale factor times the y value of your coordinates. So the first thing we need to do here is find the coordinates for each vertice. And so the coordinate for P is 2, -1. The coordinate for Z is -2, 1. And the coordinate for G is 0, -2. And so we simply want to take our scale factor, and in this case it is 2, and multiply everything by 2. So that's what I'm going to do. So for P, our P prime is 2, -1. So multiplying that by 2, 2 times 2 is 2. 2 times 2 is not 2. Erase that. 2 times 2 is 4. And 2 times -1 is -2. All right, and for G prime, multiplying 0 times 2, that is just 0. And 0 times -2, that is -4. And for Z prime, -2 times 2 is -4. And 2 times 1 is 2. So I just took everything, multiplied it by the scale factor, and in this case the scale factor is 2. And so this is just the ordered pair is a little neater. So for P prime, 4, -2, Z, -4, 2, and G, 0, -4. And then we would just, if we had to graph, we would just take our graph and plot our new ordered pairs. So as you can see right here, we have Z prime, which is -4. I'm sorry, not -4. 4, -2. We have G prime, 0, -4. And we have P prime. That is at 4, -2. All right, so the last problem we're going to try here, it says graph and label the figure and its image under a dilation with the given scale factor. So we have triangle WXY with vertices -4, 8, 10, 0, and -2, -8. So I already have the pre-image ordered pairs plotted here. I'm just going to label them. So this is W, this is X, and this is Y. And our scale factor of K, because K is a scale factor, is 1/4. So automatically we know that this is going to be a reduction because our scale factor is less than 1. So our figure or our image will get smaller. So I'm going to go ahead and just connect these dots here. Very hard to draw a straight line, but this should be a triangle. So I've connected my dots. All right, and so I'm just simply going to take each one of my ordered pairs and just multiply it by 1/4. And if you're multiplying anything by 1/4, you're really just dividing by 4. So just like if you were multiplying anything by 1/2, you're dividing by 3, and so forth. So I'm just going to take each one of my ordered pairs and multiply it by 1/4, or simply divide it by 4. So I'm just going to put 4 underneath. So my W prime would be -1, 2. Next, dividing by 4, same as multiplying by 1/4. That is going to be 2.5, 0, and -2/8 for y. That is going to be -0.5, or 1/2, and -2. So I'm just going to plot these points here. So my first ordered pair I'm going to plot is -1, 2. So back to -1, up 2. That is my W prime. 2.5, 0 would be right here. And that is my X prime. And -0.5, -2. So back to -0.5, and then down to -2. That's going to be Y prime. And connecting my points here. So as you can see, my image is smaller. So that tells me that that is, in fact, a reduction. So I have graphed and labeled this figure and this image under a dilation with the scale factor of 1/4. Okay, so we've reached the end of our lesson, and thank you for learning with me. I have related videos on translations, reflections, and rotations, and so if you want to see more videos, please click the playlist and subscribe to this channel and click the bell to be notified when I post any new content. Again, thank you for learning with me.